This is Mr. Potter. What I want to do today is I want to take some of the stuff that we learned to do with strings and also with the array lists, but I want to kind of incorporate it with this ongoing project that we've been working on all year, this fraction class that we wrote. So remember that we had this fraction class that we wrote. It implements the comparable, which means we have the compare to method. And that's nice because that means we have access to the sort that we talked about in our collections class. We also have all these constructors. We've got two private instance variables. We've got a default constructor, several overloaded constructors, accessors. We've got some mutators, and we've got our toString, which allows us to print the object out. What we're going to do is we're going to set up a file here, but this is actually going to manipulate files on our behalf. So I'm going to create an array list of fractions. So I'm going to do ArrayList fraction, and I'll call this FracList gets new ArrayList of fraction. And then what I'm going to do is I'm going to add some fractions to this. For int I gets 0, I is less than 100, I plus plus, and what I'm going to do in here is set up a real quick. I'm going to do int numer is going to get cast as an int math dot random times 100, and int denom is going to get int math dot random times 100 plus 1. Again, I'm putting the plus 1 in here because I don't want the denominator to ever be 0. I'm going to create a new fraction. So it's going to be a new fraction with the numerator numer and denominator denom. So I'm using the two parameter constructor that we originally made. With the semicolon, and then I'm going to go ahead and add this to my list. So FracList dot add frac. And then what I can do is I can system dot out dot print line FracList, and this will print out a whole bunch of these. Now I need to make sure that I actually compile this fraction class, make sure I have a class file that goes with it, because our fraction file runner will be accessing this class file. So now I should be able to compile and run this. Well, I forgot to include my import statement. That would be quite helpful. Remember that we are dealing with ArrayList, so I need to do import java.util.ArrayList. So let's go ahead and get this to run. And there is my list of fractions. Now, if I wanted to, I could sort these fractions. I could reduce all these fractions. I've got a pretty good thing going here. What I want to do, though, is I actually want to write these to a file. So there's several things that I need to do here. The first thing I'm going to do is talk about this try command. The thing is, dealing with files is a bit troublesome. The thing is, you don't know if a file is going to exist, and you're trying to create a new file that overwrites a previous file, or if you're trying to read to a file and the file doesn't exist, or you're trying to write to a file and you run out of disk space, or you're trying to read from a file and then all of a sudden the hard drive fails. You have no idea what's going to happen. And so what we do is we try and cajole Java to make sure that it does what we want to do. When we say, try this code out. Something bad might happen, and that's okay, but we want to try this code. And then what we do afterwards is we try and catch an exception. Some exception which I'm calling E, and in this code we'll do something with the exception. Because we have no idea what it is. The thing is, this is the code we're going to try to do something with. And then this is where we try and catch the exception to make sure that, if there was a error, we try and exit the program gracefully. We don't want the program to just crash and halt. We want to try and end the program gracefully. So what I want to do is I want to write a new file. So I'm going to create a file object, and I'm going to call this out name. This is going to be the name of my output file. So this is going to be a new file with a particular file name, which I'll call output.dat. And so that means that if I want to refer to the file name output.dat, out file is the file object that points to it. And so everything I'm going to be doing is going to be dealing with this out name. So now I want to do a file writer. Which I'll go ahead and call writer. Gets new file writer with my out file as the parameter. And so this is the actual device that I'm going to be using to connect the output stream that I'm going to create with the file name. And now I need an actual device to write to. So I'm going to say buffered writer. We'll call this BW, gets new buffered writer. And the parameter is going to be my writer. Now, the whole idea that we're doing here is we're doing three things here. One is I'm creating a link in Java to a file name. And that link to a file name is called out name. Then I'm saying, hey, I'm going to be writing to a file. So I'm creating a link from the ability to write to a file to a particular file name. And that's what I'm doing on the second line. And then I'm saying, you know what, I need to find a way to write so that everything gets pushed at the appropriate time. That's this buffered writer. In other words, when I'm done with the last write statement, it actually gets written. Because hard drives tend to save data when it's convenient for them or when it's the right spot in memory, and we need to say, no, you need to do this now. It's a little bit slower to do this, but it's much more safer to do this. We actually get a much more reliable output. And once I've done this, now I want to go through my loop, go through my list. So for, we'll call this fraction f in frac list. I'm using the for each loop. And what I want to do is I want to bw dot write, and I'm going to write f. Remember that if I'm doing this, I'm basically calling on the toString method that we have down here. That's going to print the numerator and a slash and a denominator. And I want to go ahead and add a backslash n. So in other words, in my output file, all of these fractions are going to be on a new line. And then once I'm done, then I want to tell my buffered writer to close. And what this is going to do is this is going to say I'm done writing the file, save everything to the file. Now you notice that I've got a lot of things that are not traditional stuff, and so I need to make sure that I import all of these things. And all of these are found in the IO branch of Java. So I have import java.io.file, import java.io.file, uh, file writer, and import java.io.bufferedWriter. So I've got three different things that I'm using here: the file writer, and the buffered writer. And our fraction class is already written, so let's go ahead and compile this, make sure it works nicely. What did I do wrong? Out name. It's not out file, it's out name. Silly me. And so I'm going to go ahead and run this. And notice that it's going to print out the array, but I've also saved it to disk. So let me go here, file, open, and I'm not going to open Java files. I'm going to look at all files, and in particular, I'm looking for output.dat. If I open this file, what I'm going to see is a whole list of the fractions. I've saved it to disk. Notice these fractions are in the same order that I've got here. So this is how I actually write to a file. Now, in here, I want to make sure, you know, if I'm doing something, I want to do system.out.println, something went wrong, trying to write the file, just so I know that something happened there. And this tells me where the mistake actually happened. So if I get this as an error message, which, let me go ahead and preface that at the beginning with ERR, so I know that that's an error message. If I see this, I've got this something went wrong trying to write the file. One of the things that could be wrong is if I try and run this while I still have output.dat open, that could cause an issue. So I'm going to go ahead and close this file so that's not an issue. So now I've got this array list that I've saved data into, and now I've saved this all to a file. So the next thing I want to do is I want to try and read from the file. So what I'm going to do is I'm going to say FracList gets new array list of type fraction, and of course this is going to clear out the array list. There's not going to be anything in here anymore. So what I need to do now is I need to find some way to get the data from the file back into my array list. And so I need to find some way to read from a file. So I'm going to go ahead and set this up the same way. Again, anytime I'm dealing with file stuff, I'm going to have to do a try statement. And then afterward, I'm going to have to try and catch an exception. And I need to make sure that I do what I'm trying to do that's quirky, and then print out some type of convenient message to allow us to exit gracefully. So in my try thing, I need to set up an outbound file. So I'm going to go ahead and say file in name gets new file, and I want to read from the same file I just wrote. So I'm going to call it output.dat, but I'm not often going to have the input file name and the output file name be the same. It's just for this one convenient thing. Then, the same way that I read from the keyboard, I want to read from this file. So scanner in gets new scanner with my in name. And so now I can just use in the same way that I would read it in from a string. So what I want to do is say while, because here's the thing. If I'm not in the file, I have no idea how big the file is. I knew exactly how many items I want to write to the file because I had those items beforehand, but I have no idea how many items I'm going to read in. And the way that I check this is with in dot has next. And the has next is a Boolean method that's going to be true if there's still stuff in the file left to be read, and false if it's not. And I want to read in these things from the file. Keep in mind that the file is made up of strings, so I'm going to have string data is going to get in dot next. And then this is the tricky part. I need some way to create a fraction from the data. And because I need a way to create a fraction from this data, I need to make a constructor. In other words, I need a constructor for fraction that's going to deal with a string. So I have this default constructor. Yeah, let's go ahead and save the. I have this default constructor. Hello? Well, then. Well, that was exciting, but it was also an example of what actually happens. What we have to be careful of is that, you know, my Windows decided it really, really, really wanted to restart. So we restarted Windows, and I'm having to reopen all my files. So again, this is why we have the try catch block. Not at all planned, but always the accidental stuff is the best lessons to learn. So where we were is we had our in name, and we were trying to read in from a file, and we noticed we need to be able to create a data, create a fraction from the data that we read from the file. And that means in our fraction class, we have a constructor that's default. We have overloaded with 2 int parameters. We have overloaded with 1 int parameters. And we're going to add one more constructor here. So we're going to have an overloaded constructor. And it's going to be a string representation of a fraction. Like 34 over 56, something like that. So I'm going to have a public fraction and I'm going to have a parameter string frac. And what I need to do is I need to look at this frac, and I need to figure out where the numerator is and where the denominator is. So what I really need to know is where is the vinculum, the slash that separates the numerator from the denominator. So I'm going to say frac dot index of, and my vinculum is going to be the slash here, and I'm going to store that in a variable called loc. And I know that everything that comes before it has to be my numerator. So my numerator is going to get integer dot parcent whatever comes in front of the fraction. So it's going to be frac dot substring, and I'm going to start at 0 and go to loc. And my denominator is going to be integer dot parcent with fraction dot substring starting at loc. Because remember, if I have a representation like 3, 4, / 5, 6, this is position 0, 1, 2, 3, and 4. So if I do from 0 to loc, I'm doing from 0 up to, but not including the 2. I'm doing something that's 2 characters long, and so it's going to be the 34. And if I do a substring starting at position 2, then that's going to give me the /56. This really should be loc plus 1. So just making sure that works out, making sure the logic works. I think I'm actually going to do a test real quick, just to make sure it works. So I'm going to say ArrayList dot add, and I'm going to add a new fraction of type data. And of course, my catch, that thing I have to be careful of here, is I need to say system.out.println, and I'm going to have an error, something went wrong trying to read this file. And one other thing I forgot to do is anytime that I'm reading a file, I need to make sure I close the file. So I need to do in name dot close. So this is going to close the file for me. I need to compile my fraction class to make sure it's good. That works. I'm going to compile my fraction file runner. Got some errors here. Let's take care of them. Oh, well, I've got a scanner. I need to make sure I import that. That's part of util. So I'm going to have to import java.util.scanner. And I thought I had another error. Let's see what that is. Oh, that's right. I'm not going to close this file. I actually want to close the scanner. So I want to do in dot close. Okay. So let's run this, and actually let me do one thing, make sure I'm actually doing this right. At the end, I should end up with the exact same array list that I had before, because I'm reading it in from a file. So if I do FracList and print this out, then here's my original fraction list, and here's my new fraction list. Let's go ahead and make sure this matches up. I start off with 13 over 87, 70 over 73, 98 over 100, and my very last fraction is this 89 over 76. I printed it once at the beginning, and I printed it once at the end. So what we've done here is we've used this concept of the array list to kind of store data. If I wanted to, I could collections dot sort my frac list, as long as I make sure that I import collections. Java.util.collections. And then I could print out the result afterwards and see a nice sorted. Sorted fraction list. And so I end up, fraction of 0, very, very small fractions, small fractions, leading up to larger fractions, 58 over 1. And of course, all these fractions are random, so I'm going to get different results every time, and that's perfectly fine. But anything that I've done in the past with the collections class, which we talked about in our last video, I can do with this array of fractions because they are sortable. They do have that compare to method in there. And all of the stuff that I did with the array list, I can do. So notice I created array list. I did array list dot add. I did the for each loop with the array list. I could remove fractions from this. I could find the index of a particular fraction. I could even go through and say, you know what, every fraction in this list I want to reduce. And I could probably do that using a for each, because it's not going to destroy the array list. It's not going to destroy the order. I'm not going to remove things from it or change the order. I'm just manipulating the data inside. And that's perfectly fine. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.